All right, so exam review, chapter 1. It says write an algebraic expression for each word phrase. Does an expression have an equal sign?
No.
No, that's an equation, right? This is an expression. So there's no equal sign in this. What is a product? Times. Okay. A number W and 737. What is the best way to write the product of a number W and 737? 737W. Okay, the product of a number W and 737. All right, number 9. 9 more than the product of 51 and a number T. Do you remember more than and less than, what we said you always do with that? You swap them, right? Whenever you see more than or less than, we swap them. Now, one of them, it doesn't matter. Which one does it not actually matter if you swap them? More than, because addition is commutative. So you can add this way or you can add this way and it's fine. But with less than, you absolutely have to swap them, okay? And I promise there's one on your final like that. Swap them for less than, okay? 9 more than the product of 51 and a number T. How would you write that? 51T, so that's the product of 51 and T plus 9, right? So whenever you see more than, flip them around, which one's where? Okay, so now this one's less than. See if you can write that. 14 less than the quotient of 63 and a number H. Try that yourself. What does quotient mean? Division. Okay. So how did you write this? 14 less than the quotient of 63 and a number H. Brody, what'd you do?
63 over H. Minus 14.
Yeah. So this is a beautiful way to write it. If you wrote it this way, that's fine too. Okay, quotient is division, so you can do that. Either one of those is a perfectly good answer. Questions on that at all?
How do you just remember, I don't know, I just don't understand how to put it into that. I just don't.
So you just have to know what different words mean, right? When you see less than, you should think, I gotta switch things around, and less than is subtraction, right? When you see a word like quotient, you gotta think that's division. So the quotient of this means you are dividing that. So 63 divided by H, right? And then less than just means flip-flop where they're at. So, and subtraction, right? So the 14 needs to go to the end. The 63 and the H need to come to the beginning. So look for keywords like that. Less than is flip it and subtract it. Okay? So it's really just a matter of making sure you know what words mean in this stuff. If you want, I mean, we can make a list at the end of this of all the different words and what they stand for. We can do that. And honestly, put a sample problem, like put number 10 on your note card and then write it, the answer and the wording, and that will help you to see, like on your final, here's how I should do it. Okay. Okay. 23 says simplify the expression. Now, I would absolutely, if I were you, write PEMDAS on your note card, but maybe with the words, if that helps, if you need it, right? Parentheses, exponent, multiply and divide. Okay, those happen left to right, and then add and subtract. Okay, because you want to make sure you follow PEMDAS. And I know at this point, you've been doing PEMDAS for so long that it feels like a no-brainer sometimes. But I think the things that feel like no-brainers are often the things that get done wrong because people just rush through them because you're like, oh yeah, I know how to do this. And then you make a silly mistake. So my encouragement to you is on the final exam, slow down. take a deep breath, one thing at a time. If you get stuck on a problem on your final, skip it, okay? It is not in your best interest to spend 10 minutes on one question that's frustrating the heck out of you, because then guess what? You're super frustrated, and then you move on to another question, and your brain is in frustration mode, okay? If you get to a problem on the final and you're like, I don't remember, don't give it any of your brain space. Move on. Just make sure if you move on that you skip to that number when you're filling in your bubbles too, okay? But fill in what you know. Do the stuff that's easy, because that's going to build confidence for you. And then once you do the stuff that's easy, then go back and do the things that were tougher. I'd rather you get the points for the things you know how to do than spend a half hour on something you don't know how to do and not get to the things that you do know how to do, okay? So just do the ones that are easiest first and go back and do the harder ones later, okay? Okay, so PEMDAS, what do you do first on 23 here? Multiply what? Right, 7 squared. You're doing the exponent, right? This is the E in PEMDAS. So 7 squared is 49 divided by 5. And then you can either write that as 49 fifths, which I don't recommend because that's just not a lovely number. Or if you plug that into your calculator, that is 9.8, okay? All right, 24. This one is a little tricky because there's multiple exponents happening here and there's parentheses happening here. So you have to think about, what do I need to do in what order? What would your very first step be? 2 to the power of 4. You're doing what's in the parentheses first. Okay, so we need this fully simplified before we try to do anything else. That means 2 to the 4th power. Anyone know what 2 to the 4th is?
16.
It's 16. Okay, so now it looks like this. 16 minus 6 in parentheses, and we're squaring. What do you do next? Square or subtract? Subtract. You have to do what's in the parentheses. So 10 to the 2nd power. And what is that? 100. Please put boxes around your answers, by the way. You guys are usually pretty good about that, but it's very helpful for me. All right, number 28. This is CD squared plus 4. Now, here's my question for you. They give us 2 values. C is 3, D is 5. We'll get there eventually. I need to know, what does this mean? CD squared. What is squared? It is to the 2nd power. What here is being squared?
D.
Just D. It's not CD. If it was CD, they'd put parentheses around it, right? If there's no parentheses, you're only squaring the thing that squared is next to. So don't multiply first. You need to do the exponent first, okay? There's no parentheses here. So we're going to say this is 3 times 5 squared, right? No parentheses, plus 4. So now we do the exponent, and then we multiply. A lot of people do this one wrong. A lot of people try to make it 15 squared and then plus 4. You want to do 5 squared, so 3 times 25 plus 4. And that becomes 75 plus 4, and then you can add together. So that's 79. Questions on that? Okay, this one is a little tricky just because of how the work comes about. But I believe in you. It says a race car travels at 205 miles. Oh no, that's not the one I'm thinking of. This one's not that tricky. 205 miles per hour. How far would they travel in 3 hours? What do you do? This one's not tricky at all.
205.
Right. If it's 205 miles in 1 hour, right? What they're saying is, how many miles is that in 3 hours? So you can set it up like that, or you could just do this one in your head. If it's 205 miles for 1 hour, multiply that by 3, that would be 3 hours. But really what you're doing is cross multiplying and saying x equals 205 times 3 is 615 miles in 3 hours. Okay, if it's a word problem, make sure you're labeling so that we know what you're working with here. Okay, here's something I would put on your note card, is all the subsets of real numbers. So we had real numbers, right, was the big overarching thing. And then under real, there was rational. And then I'm going to go way down here. There was irrational. Write this on your note card. What makes something a rational number?
It ends.
A terminating decimal, right? So terminating decimal, like 2.75, right? That's a rational number. What else makes something a rational number? A fraction, a over b, if you can write it as a fraction, or a repeating decimal, 2.6 repeating, right? That's 2.2 thirds. So those are the things that make something a rational number. Essentially, it's if you could write it as a fraction, it's a rational number, because all of those, this is 2 3/4, this is 2 2/3, and then 2/3 or something. Those are rational, okay? So irrational can't be written as a fraction. Give me an example of an irrational number. Pi. Or a decimal that's funky, 1.010010000. Like that's a pattern, but it's not a repeating decimal, right? Or a repeating pattern. Or like the square root of 2, right? That's an irrational number, okay? Under rational then, we talked about several different kinds of numbers. So under rational, we talked about natural numbers. What's a natural number? 1, 2, 3, the counting numbers, right? 1, 2, 3, 4, and so on and so forth. What's a whole number?
0.
Right. Whole numbers are the natural numbers and including 0. 0, 1, 2, 3, and so on and so forth. What's an integer? Oops. It does include negatives, but is it a negative decimal? No. It's got to be the whole numbers with their negative. So like -3, -2, -1, 0, 1, 2, in both directions, okay? No fractions with integers, okay? Questions on any of those? Okay, so then tell me, which subsets would -17 fall under? Is that rational or irrational? It is rational. Everything's real, okay? All of ours are real numbers. So this is rational. It's also what? An integer. Is it a whole number? No. Is it a natural number? No. So it's just these two. It is a rational number and an integer. How about 40? 13 over 62.
It's rational.
It is rational because you can write it as a fraction. Is it anything under rational? Natural, whole, integer? Nope. So the most specific you can call this is a rational number. What about the square root of 94?
Irrational.
That is irrational. Here's where you have to be a little bit careful on these. Okay, what if I gave you the square root of 16? Is that irrational? No, because the square root of 16 is 4. So if it's a perfect square, then it's going to be rational, natural, whole, and integer. Okay, if it's not a perfect square, like the square root of 94, then it's irrational. Okay. Okay, here's where they get a little bit fancy. And these are the ones that I really need you to just take your time on. Pay attention to parentheses. Pay attention to where things are squared or where you multiply or where you divide, things like that. 68, it says P is 5, Q is -3. So for all 5 of these problems, those are your values for P and Q, okay? This says a negative parenthesis 4. What operation is happening between 4 and Q? Multiplication, right? When they're next to each other, you're multiplying them. So it's 4 times a -3. What's your first step? Multiply. 4 times -3 is a -12. And then there's that negative out in front. What is the value of that? No. Oh, the negative is a -1. Yes, sorry. You can treat that like a -1. So that equals a +12. It's the opposite of -12, right? It's a -1 times a -12, which is a +12. Okay. All right, number 70. You have 5 times P, which is 5, minus 6. So that's 25 minus 6, or 19. That one's pretty straightforward. This one gets a little fancy again. You have a negative parenthesis 2 times 5 squared. What do you do first? 2 times 5. So there's a negative, this is 10 squared. What do you do next? The exponent. So 10 squared is 100, so you have a negative and 100, and that's your answer, okay? Don't do -10 and square it. That'd be a +100. This negative is your last step. You have to square before you can essentially multiply by a -1, right? All right, 73. What are you going to do first? 5 times -3 and then square it. So this is a -15 squared. Tell me how you're going to plug that into your calculator.
Parenthesis, -15 parenthesis.
Right. If you type into your calculator -15 squared without parentheses, your calculator is going to tell you -225. Okay? You need to square the negative, which means it's going to become positive, right? So put it in with parentheses so that your calculator knows that. That is a +225. Okay. 74, you have 2 times -3 divided by parentheses 4 times 5. What do you do first? You can do the 2 times -3 at the same time as the other thing you're supposed to do first. You always do parentheses first, right? And the thing in parentheses, the only thing we have right now is the 20. So it's 2 times -3 divided by 20. What do you do next? Now you can do the 2 times -3. So -6 divided by 20. Maybe a nicer way to write that is -6 over 20, which would be a -3/5. I would say that's the best way to give the answer, but another way you could do it is if you just plug that in, you get what? 0.6, right? A -0.6. What?
The 20 turns into
Oh, I messed up. You're right. Sorry. This is not a 5. My bad. Good catch. Sorry. -6 over 10 is -3 over 6 over 20 is -3 over 10, which is a -0.3. So this or that are good answers. Okay. Okay. What do you do on 75 here? Distribute. So you're going to go 5 times 2x is 10x. 5 times a -3 is a -15. What do you do from there? Put a box around it, right? You're done. 10x minus 15. So what do you get on 76 when you distribute?
-14 plus 2a.
Yes, minus a negative. So -2 times a -a is a +2a. So -14 plus 2a. What do you get on 78? 3v squared minus 2v squared is? 1v squared. You can just write that as v squared, right? You don't need to put the 1 out in front. If you put the 1 in front, I don't mark you wrong, but you're just combining like terms. So what do you do on 82?
Y minus 3.
5 what?
Y minus 3.
Oh, y minus 3. Yes, you're going to start with the like terms. 6y minus 5y is 1y, but then you also have the minus 3. Okay. All right, last one. Tell whether the given ordered pair is a solution of each equation. How do you do that?
I forgot.
Plug it in. This is an X, this is a Y, right? So plug this in for Y, plug this in for X, and see if it's a true equation. So 3 times 1 plus 5 would have to equal 8 if this was going to be true. So 3 plus 5 equals 8, which means 8 equals 8, and that checks out. So is it a solution? We would say yes, that is a solution. Chapter 1. Doesn't this feel nice? It's like so simple now, right?